In this portion of the video, we're actually going to do our calculations. We're going to combine what we learned about binary numbers with what we learned about subnets and how they work in order to calculate some fairly complicated things for subnet masks. Now, why do we need to do this? Well, it's because when we're managing and allocating IP addresses on networks, we need to be able to know how to break up things into subnets, and this is what network engineers do. Also, these sort of calculations are required if you ever take any certification exams, like any of the Cisco exams. For example, the CCNA, you'll need to know this without being able to look at a cheat sheet or an online calculator. You'll need to understand the concepts and be able to do this kind of calculation, or have them all memorized. And so let's look at this particular IP address. In this case, we're using a 192.168.1.1 example. So we'll do a little bit, our examples kind of like the simpler ones last time, and then we'll work our way up. So in this case, we're doing an example very similar to the ones we did before. With 192.168.1.1 is our IP address. Let's say that that's our wireless router, our default gateway. And our subnet mask, again, is 255.255.255.1, okay? Or this is a /24 is our shorthand, CIDR shorthand, which, tells us there's 24 bits in our subnet mask. The first 24 are all ones, and the last 8 are all zeros. And so if we were to convert the IP address right here and the subnet mask into binary, here's what they would look like. Okay, so this is 192.168.1.1 in binary, and this subnet mask is what 255.255.255.0 is in binary. And so what your computer is actually doing behind the scenes is a calculation called bitwise AND. What that means is it's going bit by bit, and it's looking to see if both of the bits are ones. If they are, then the resultant number is a 1. If they're not, if neither of them are ones, then it's a 0. Or if one of them is a 1, it's a 0. So for example, if we go through in this first octet, the first bit in each of these is a 1, which means that our network, our subnet, our network address is a 1. The second bit, they're both 1s. The third bit, only the subnet mask has a 1, but the network address, or the IP address, doesn't, and so that becomes a 0. Similarly with the third, there's only one of the two, and so on. And so if we go on a little bit further, you can also see some scenarios where both of them are zeros, and that's also a 0. So it's only where both values are ones that the network portion becomes a 1. Okay? So for example, right here, both values are 1, and so this value becomes a 1. So that's what your computer is doing behind the scenes in order to find the network address or of a particular IP address, or the lowest IP address in that particular subnet. That's how subnet masks work. So if we convert this resultant value, okay, this bitwise AND result of these two numbers, if we just convert it to decimal, because I still think in decimal rather than binary, then here's our address, 192.168.1.0. And we knew that because we've seen that before, and we knew that, okay, well, with this particular address, the last octet is the one that defines things, because it's on the octet boundary, that 0 is the lowest number and 255 is the highest number, but 0 is the network portion, or is the network address, and 255 is the broadcast. And so we already knew that. This is fairly simple, but it gets more complicated. So in this case, here's our first host address. It's simply the one higher than the network address. And here's our broadcast address, which is simply the highest particular IP address that's in this subnet with this subnet mask. So let's get a little bit more complicated. Oh, and we've also got the value in this worksheet. We've got the value of what is the maximum number of hosts per subnet. Well, we can calculate that. Okay, so it's simply the number of potential IP addresses, based on our subnet mask, 2 to the 8th, or 256, minus 2, minus these this network address and this broadcast address. All right, so let's get a little bit more complicated. Let's instead do an example where our subnet mask is not exactly on the network boundary. Okay. So we've changed it to 255.255.254.0. Okay, so this is a /23 network, or that means that there are 23 ones in the subnet mask and 9 zeros. So the last 9 bits determine or tell us that the last 9 bits of the IP address are the ones that are the host address. Now with 9 bits as 0 in the subnet mask, that means we have more potential hosts, 2 to the 9th minus our 2 reserved IP addresses, and so we have 210 potential hosts that we can assign in this network. Now this is where we get a little bit trickier. Okay, so you might be able to tell that when we do our binary math, okay, so when we put these together and we do our ones and zeros and then we convert these, convert this binary resultant of our bitwise AND, if we convert this back, then here's our subnet address, okay, our subnet ID. So this 192.168.0.0, which is actually the same as it was in the last example. And the first host is simply one higher than that value, which is exactly the same in the last example. But our broadcast address is different, okay? It's actually, rather than 192.168.1.255, it's actually 192.168.0.255. It's 192.168.1.255. Now, why is that? Well, it's because we have more hosts. Because our subnet mask is 255.255.254.0, and we have a maximum size of our subnet is 200 or is 512 minus our 2 reserved addresses. And so if we were to try to find our broadcast address, here's what we need to do. We need to say, okay, well, what's the highest value that could be put in here? Okay, so if we were to change the subnet mask to all ones, for example, what's the highest value there? Well, 255 is the highest value. And then if we were to say, okay, well, what if we just changed this, only this one portion, or this 0 in our subnet mask right here, if we change that to a 1, what would be the highest value here? And so essentially what you're doing is, you're doing kind of the opposite of the subnet mask. If you were to switch all of the 1s to 0s and 0s to 1s, and then add the resulting number to our network address, then here's where we get our broadcast address. All right, let me show you a little more complicated example. So let's pick an IP address. Let's do 10.210.4.54. And let's say our subnet mask in this case is 255.255.248.0. Okay, so what, let's not do 248, let's do 240. Okay, so what that means is that in our subnet mask, the first 2 octets are all 1s, but our third octet, half of the bits are 1s and half of the bits are 0s, and our last octet, of course, all of them are 0s. So in this case, this is a /20 address. 20 of the bits are 1s, and then we have 12 bits that are 0s. Our maximum hosts per segment, we have, well, 496 total, okay, 2 to the 12th, but we subtracted 2 out, so we have a maximum number of hosts of 4,094. And here's how we find our network address. We take our IP address, which is just this number in binary. We have our subnet mask, which is simply this number converted to binary, and we do our bitwise AND. So we go, bit by bit, and we look, okay, are both of these 1s? No, they're not. That's a 0. Both of these 1s? No, they're not. That's a 0. And so on until, are both of these 1s? Yes. Okay, then that's a 1. And so on and so forth until you get the network address. Convert that to a decimal value, and now we have, here's the network address, 10.210.0.0. That's the network address, which means our first host is simply 1 higher than that value, 10.210.0.1. Now here's how we have to calculate what is our broadcast address in this case. So here's what we do. We kind of switch our, let me write this in, we switch our subnet mask around. At least this is how I think of it. So we have, in this case, we have 8 zeros. In this case, we have 8 zeros. In this case, we have 4 ones and then 8 ones. So this is how I think of it. This is the value that we need to add to our network address in order to come up with our broadcast address. And so, in this case, we just add 255, which is all ones, to our broadcast address. And in this case, we're going to add, we can calculate this. We can convert it to binary. How many ones are there? Okay, well, there's 1 plus 2 plus 4 plus 8, which gives us 15. And we just add that 15 to our network address, and that's what we get for our top address. We do the same thing for the others, but these happen to be 0, so we don't add anything. And so that's how we calculate our broadcast address, which is actually probably the trickiest part of this process, is to figure out how the broadcast address is calculated. Okay, let's do one more. Let's pick another address. So let's do what the heck? Let's do Google's DNS server, which is 8.8.8.8, and let's say that we're using a subnet mask of 255.224.0.0. I don't know what Google's using, but let's just assume that we're using that for right now. So in that case, our subnet mask, when we convert it to binary, becomes 255 all ones in our first octet, and then our second octet has 3 ones, and then the rest zeros, and then of course our last 2 octets all have zeros. So this is a /11 address, okay, so because we've got 8 ones here. So in this case, we can go do our bitwise AND comparisons and come up with, this is our network address. Okay, so we simply go through and say, okay, 0, 1, that's a 0, 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 1, 1, that's a 1, and then so forth. And then based on that, we can convert that back to binary, or I'm sorry, back to decimal, and we get the 8.0.0.0 address. Our first host address is simply 1 higher than that, 8.0.0.1. In order to calculate the broadcast address, we do kind of the, what I think of as the opposite of the subnet masks. So in this case, it would be 0, 0, 0, 1, 1, 1, 1, 1, and in this case, all 1. And so in this case, we add 255 to our network address. We add 255 to our network address. And in this case, we add up, the binary value for 11111, which happens to be 31, and we add that to our network address to get our broadcast address. So let's do one more example. So rather than having a fairly large subnet mask, let's have one that restricts our subnet to be a smaller number. So let's go back to let's go to some private IP address space. Let's do 10.20.30.45. All right, so let's go ahead and do that space. And rather than having one with a lot of different hosts, for example, our last example had 2 million different plus hosts. Let's go and switch this out so that we actually have smaller than what was a Class C network. Let's divide this up to 255.255.255.248. All right, so obviously I've made this calculator that does some of the math for you, but you're going to want to learn how to do it manually and not use a calculator. Well, not use a calculator that calculates everything for you, because you're going to need to know it, without those sort of helps. So here's how we translate a IP address into binary. So we can just do the calculations and do that. We translate this subnet mask into binary, and it looks like this. And then we do our bitwise AND, and we end up with the network address. We can convert that into decimal, and then here's our particular network address for this subnet. It's 10.20.30.40 is our network address. Our first host becomes 1 higher than that, 10.20.30.41, and our broadcast address is the highest address in this range. Well, how do we figure out what that is? Well, we can either memorize the chart, or we can go ahead and put in kind of what I do is I calculate the kind of the opposite, flip all the ones to zeros and zeros to ones in the subnet mask. and 111 in binary is simply 7. And so we add the value of 7 to our network address, and that becomes our broadcast address in this case. And all the others are 0, so we don't have to add anything. So in this case, our subnet is only a maximum of 8 IP addresses, 2 of which are reserved. So we only have room for six different hosts. So our first host could be 10.20.31.41, and our highest host could be 10.20.30.46 with a broadcast address of 10.20.30.47. So for example, I may ask you questions such as what's the network address of a particular IP address with this subnet mask? Or I might ask you what's the first host? Or I might ask you what's the highest host, which would be 10.20.30.46. Or I might ask you what the broadcast address is. Or I might ask you what the maximum number of hosts are in that particular subnet. So there's a lot of different calculations that we're going to work on, and you'll need to know how to do them, and you'll get much better and better with the binary math as we go.